Whoa. There we go. Okay, so let's start old school. Spring, boom. What do I have to do to compress the spring? Work. And if I do,
No, you're good.
if I do just a little bit of work, I only store
A little bit of energy.
a little bit of energy. There you go. Not so impressive. If I do more work, I store. Whoa. Whoa. Okay.
Whoa.
If I do more work, I store
More energy.
more kinetic energy, right? So the more work that I do, the more potential energy that I store, the more kinetic energy I get out of it. Okay? Nice. All right, so I'm going to take yonder balloon, and which right now is neutral. So discharge. Do a little Jedi mind trick here in just a second. So put that over here. Okay. So do a little Jedi thing and take my hand and drag it without touching it. Okay? So, does that mean, this is going to be important, old school electric fields. Does this mean my hand is, because we know that's negatively charged, does that mean my hand is positively charged?
No.
What's happening?
Neutral.
It's inducing a charge, and the chihuahuas are running away. I gotta get this charge up quick. Hold on. There we go. Okay. Better. Shadow mind trick. I can drag it. Now, I'm going to do the same thing. Second balloon. Okay. And wait. So I'm going to charge this balloon as well. Now, so these balloons are both. Whoa, hello, come back. I'm thinking of potential energy. Now, when I bring these together, oh, come on. I hate when physics doesn't work. Andrew, somehow this is your fault. Cohen, I might have to borrow your hair. So when I bring these together and let go of them, that one, now, when I push them together, am I doing work?
Yes.
Yes, okay? So this is like two like charges. So this would be like two protons or two electrons. So when I have these, Cohen, come here. Cohen's hair works incredibly well for this. Hold on.
Oh no. Oh no.
We need more tape.
Oh, I think it's attracted to the blanket.
That might be that. Okay, hang on.
It's all on video too.
I'm not
It just has to be on your plastic shirt.
Clip it.
Clip it.
There we go. Okay, so I'm doing work, and these don't want to be near each other, right? Because if I push them together, as soon as I let go, what do?
Go away.
Far away.
They go away. So this is kind of cool. So we have this invisible field that we can't see. So if I put my hand in between, I can make them come together. Oh, stop. Ah! Waited too long for the dramatic effect. So if I push them together, they don't like each other and they go flying apart. But if I put my hand in between, then they become together, and then they push that away. So a force is happening, we just can't see it. But here's what I want you to see. When I do this, I'm doing work. Am I storing ooey? Yes. I've stored a certain amount of ooey. So if you look at KQ1 over D. So when I bring them together, what's happening to the value of the distance? It's becoming smaller. The amount of ooey is getting bigger. But now, when I let go of them, Mother Nature takes that ooey and converts it into kinetic energy, and that's why they go moving apart, because Mother Nature likes kinetic energy over potential energy. So imagine that I have two electrons on opposite sides of the universe. Now, I take those two electrons, which are infinitely far apart. Would I have to do work to bring the electrons together? Yes, because they don't want to be near each other. So as they get closer and closer and closer, the amount of ooey gets bigger, and because you're dividing by D. Okay? Since you're dividing by D, as ooey gets bigger, I take these electrons, which are infinitely far apart, and I push them, they're just side by side, just like this, just like these balloons. I let go of them, what are the electrons going to do? Bound. Okay? So, if I want to keep them together, I have to push them together like this. So I have to push them in the direction that they want to go. Now, visualize this. So, instead of having two negatively charged, what if this balloon was positively charged and that balloon was negatively charged? Then, if I were to bring them together, what would they want to do? They would want to come together, right? So, if they wanted to come together, I would actually have to physically keep them apart. So, if they're oppositely charged, and I put them away from each other, and if they're oppositely charged, what are they going to begin to do? They're going to begin to move towards. So imagine I have an electron on one side of the universe and a proton on the other. What are they going to begin to do?
Move towards each other.
They're going to start to move towards each other. So if I want to prevent that from happening, I would have to push them in the opposite direction that they want to go. But if it's electrons or protons, I would have to push them in the same direction that they would want to go. Now, I take a proton and an electron, and I push them together. They're oppositely charged particles, boom, they want to go together. So, in that situation, if I want them to begin to move towards each other, I'm going to have them far apart, and they're going to get closer. But if they're like charged particles, I bring them together, I let go of them, then they're going to go flying apart. That's the difference between gravitational and ooey. Got the idea? Back we go.